Hey, Laura, how are you?
Yo, what's up?
Not much. Let's see. It looks like, oh, well, Bluetooth's off. That would explain why my headset doesn't work.
Hmm.
Let's try.
Okay. Are you able to hear me?
I can hear you pretty good.
Okay, great. All right.
Yeah, I usually join early to make sure all my peripherals are going to make it.
You are
I'll make.
notoriously an early joiner, that's for sure.
I am, and it's because I have too many Bluetooth headphones and I forget who paired with who, and so I have to
Yeah.
check a bunch.
It's cool that like a bunch of them can pair with multiple devices, but I found that like that in practice is
Right.
something that I have never wanted to happen.
Right.
Yeah, I second that. And one of the latest OS X updates or iPhone updates made the AirPods quote smarter.
I know. They're
now they
not,
just switch
though.
devices. Yeah.
I know. It thinks it
Yeah.
knows what I'm doing, but it doesn't.
Like you were looking at your phone. I know you're in a meeting right now, but maybe you want to talk to your phone.
All right, we'll just give it a minute for folks to trickle in. I still haven't been able to access any trivia in my brain, and I always forget to think of, bring a little piece of trivia. But that's okay. We can talk about the weather. It's rainy here. It's got that rainy day in Stardew feeling, so I don't have to water my crops.
Nice. Between the rain and the sprinklers,
Yeah,
all the chores will be done.
that's right.
By the way, Paul, I'm going to want that sweet, sweet screen sharing at some point. If you...
Yeah, let me
don't
turn
have
that
the
on
powers.
now.
Cool.
Let me turn that on. Always prepared with a deck, Laura. Incredible.
Incredible. This one, I felt I needed to organize my own thoughts too, a lot.
Yeah, definitely. Like producing a deck is good exercise to do that for sure. Yeah. So we'll get started at 3 after. I see there's a couple people in here. Hey, everybody.
Good morning.
All right, I got 3 after. So welcome everybody to the March 16th, 2021 meeting of Kubernetes SIG Multicluster. Laura, you are up first with multi-cluster DNS, if I remember the order of the agenda correctly.
Yes.
Take it away.
We'll take it away. Here we go. Let's do our whole desktop. All right. Cool. So basically, last week, for people who were there, I briefly brought up that I want to get talking about multi-cluster DNS. I've been working on a doc for it, and to move that along some more and also just kind of bring everybody on board on what we're talking about. I made a little 101 slides, I guess, about multi-cluster DNS. So I thought I would go through these. I don't know if everybody, like, this is all old news to people, but hopefully this explains some stuff to folks either way. And as mentioned before, it was a good way to organize my thoughts and feelings. So went on that. I'm just going to go through a couple slides here and describe why and what this multi-cluster DNS proposal is about. And then in general, my call to action is going to be, I'd like people to comment on the doc and, be thinking about it so that we can move this along. So first point here is why am I even talking about this? And mainly this is a beta graduation blocker for MCS API. So we need a detailed DNS spec for multi-cluster services. So that's what I'm trying to achieve here. And then also at least one MCS DNS implementation is also listed. So, I mean, logistically, that's why. And also the current implementations right now are extending cluster local DNS in sort of a generally agreed upon way. I wasn't around, so I don't know how everybody talked about it before, but just briefly looking at like the docs for Submariner, GKE, there's some, commonalities there. And it's also kind of extending from what already is in the cluster local DNS in what I think is a sane way. But we don't have like a central standard yet. So any other implementations coming down the pipe or any future extensions, we don't have like the written document to send people to. So we kind of need that to get everybody on the same page. And the current implementations might not yet have full parity with the current cluster local DNS specification. So right now there's this specification.md file in like the DNS repo for Kubernetes, and there's like all these rules and these sections of like which records need to exist, and we don't necessarily have all of those in the current implementation. So those like serve records and PTR records in the specification for cluster local DNS enable some other like DNS related functionality that we probably also want to have for multi-cluster services. So that's why we're talking about it. And basically, for my brain, this is organized in terms of what DNS records do we need to support? And then before I go through this, the next slide is what service types do we need to support? So that's where kind of all of this proposal is coming from. So maybe everybody already knows this, but I was kind of new to all of this. The DNS records that we need to support to get parity with the current existing specification are the A, quad A records, serve records, and PTR records. These quad A records are one DNS name to one IP address. This is kind of like the most normally, I guess, thing. So an example would be like myservice.test.svc.clusterset.local, and that matches to this IP address. But then these other ones that I don't think necessarily exist anywhere in any MCS implementations yet are the serve records and the PTR records. So the serve records are look like this. So they have this weight and priority value, this metadata encoded into the response. And then they're also in this specific format that takes into account protocol port information to get these records back. So this can be used by clients to load balance for certain ports and protocols is sort of the DNS feature that we get for this. And then the pointer records are this specifically formatted DNS name, this like IP address looking thing .in_adder.arpa thing. This should match up with the human readable DNS on the other side. And this is used by DNS clients for reverse DNS lookup. So that's why these two things are like a thing that we should do, not just to have parity. Oh, Tim is having a hand. Hi.
Good morning. So small correction on the A
yes,
section.
Please do.
For headless services, it's one name to N IP addresses.
True.
Right?
Yeah.
The easy one is PTR records. There can only be one PTR record for an IP address. Like that's the rule. Well, actually, you can install more than one, but the DNS spec says don't. So I don't think we can handle PTR for this. Honestly, handling PTR at the service level was a mistake, and we should not repeat that. But even if we wanted to, we can't. So I think you can strike PTR from the plan entirely, unless somebody has a really good reason why we want to jump through hoops to make the reverse lookup of an IP address turn into the multi-cluster name instead of the local name. Given how we're implementing with like thunking through real services, you're already getting a PTR record for that IP address. It's just the bogus name.
Okay.
Now, serve records. I know some people use them. I wonder how important it is in this case. Maybe it's a place where we need to actually like reach back out to SIGNet and see how widely they're being used, whether we want to carry them forward, and whether there's any changes. I'm not super familiar with serve records myself.
Okay, awesome. This is good to know.
In other words, I'd be happy to not do serve records and then
Right.
add them later if people scream. But
Okay.
probably SIGNet would be the place to solicit more information.
Okay, cool. Anybody else want to jump in at this
So
point?
if we don't have serve records, then any client's going to have to assume a port, right? I can get the port that I need to connect to a service from a serve record. And now all of a sudden you're saying clients essentially have to hard code the ports and know the configuration. So if I have a client that wants to say, I know I want this service, having that record helps, right? It means I'm not configuring that port.
It does, but only if your client knows to go use serve records, which from my experience is very few clients.
Fair enough.
Right.
That's fine. I guess the question is then, are we, by not having serve records until there's, I guess, hard requirement, we're saying clients configure yourself to the address to which you want to connect.
I mean, one of the core principles of doing networking the way Kubernetes did networking was so that clients could do that, because that's what clients wanted to do. They want to assume that HTTPS, like this is highlighting, right? HTTPS is 443. And if it's not 443, you should probably know that. And so no reasonable client that I know of is going to go do a lookup for underbar HTTPS, underbar TCP dot whatever, and then pull the port and then go look that up. They're just saying HTTPS means 443.
Okay. No, and that's reasonable. In way back when I was playing with serve records in Kubernetes, but that was years ago actually.
I think it's an attractive nuisance. I think it's you look at it and you're like, ooh, that's interesting. Let me use that. And then it turns out like most DNS clients don't have any real support for serve records. Yep. Now I do believe it's being used in cases like VoIP and SIP, where they use not the they use the port, but they want to use the weights. And SIGNet has some open issues to actually allow programmable weights, which is something that serve offers that regular records don't.
Well, and to be fair, most times when I'm writing clients, I say, give me the address to which we want to connect. So that includes the IP and port, or service name and port.
I think
thanks.
Along the lines of that question, though, if we're not going to do serve records for now, a nice little blurb on why and explicitly stating that like we're not doing this because if HTTPS is not 443, you should know that, should be something that I think we probably write down.
I mean, I don't mind doing it. It's only stuff that we are doing and work that we're doing. I'd like to know that it's actually valuable.
Right. Well, yeah, and I don't mind not doing it. I just think that we should, for anyone who comes asking, why isn't it here when it's in the cluster local service, just a statement would be good.
Okay. So what I think I got from that, sorry, was somebody else going to say something?
Yeah, sorry. I'm just wondering if, so tying it into the topic I have on the agenda as well, whether how useful serve records would be for weighted load balancing, or if that's not really using them for what they're intended for. Because the way I remember it is this is more about auto discovery. So they tend not to be seen much in enterprisey network situations apart from VoIP. But on home networks, you get them for printers and well, you see them quite a bit for SSH on some network equipment, stuff like that. But it seems to me they could be useful just for the weighted load balancing aspect of multi-cluster services.
I mean, the same argument. I don't think there's any difference between multi-cluster and single cluster in that context, right? We're not currently programming the weights at all, and that's an open issue with SIGNet.
Yeah, so something to do up with SIGNet rather than MCS just now.
Okay, so the notes I've got here is serve records may be useful because of the weights should talk to SIGNet, and that is a just general DNS, Kubernetes DNS thing. It's not necessarily like MCS specific. So happy to go chat with them. And then for the PTR records, I'm hearing that for a given, like there can only be one record per IP address is what I heard here. Okay, so then since we will have that should already, I guess, be taken up, especially for headless cases, by like a cluster local version. And then I don't know if we have an opinion on for a cluster IP, like for the one IP to rule them all, if we want to have a.
Just to be pedantic, I think what we should think about is, first of all, if reverse lookups on service IPs is useful. We added it in single cluster DNS. I still don't know how useful it is because traffic doesn't generally come from that IP address. And so, doing reverse lookup on incoming isn't a useful concept. I think the thing to say here is IP addresses should have a PTR record. If we are using the phony in-cluster service to front end the endpoint slices for a multi-cluster service, then it already has a PTR record. If your implementation wants to use a different IP address, like you want to manage a central pool just for multi-cluster services, which I think is a valid implementation, right? Then you probably want a reverse lookup for those IP addresses. Does that make sense?
Yes, I think you're saying in the implementations to date that use this dummy service, then we already got this for free. But there probably should have be some note if that this should exist. One should exist for every IP address. And that may catch any implementations where they're not using a dummy service. You mentioned like some central pool of IPs somewhere else that they're pulling from to get the super cluster IP or cluster set IP.
Yeah, I mean, I think the spec probably here should be a should, right? I don't think we want to make it a must. I think it should just be like, we strongly recommend that you have reverse lookups if you're using your own IP addresses.
And I think as an extension of that too, if you are using the dummy setup that we have in the MCS API today, then the record that you get is not this record, right? It is for the dummy service. So so basically, if we stick with that model, then we can't be more specific than a should anyway.
Yeah. Cool. All right, going to the next slide. All right, so I think these are the service types we need to support: cluster set IP, headless. This is kind of like a little preview, and I have some other diagrams later. But like this blue pod behind the blue service should be, sorry, I need to move all your videos, behind blue.test.svc.cluster, or sorry, this is an example of what these are like today. Yeah, single cluster. So blue.test.svc.cluster.local will get you to this blue pod. Yellow.test.svc.cluster.local can get you to these two pods for a cluster IP service. For headless type services, you'll get stuff like blue.test.svc.cluster.local, or if you have host names on your pod, you'll get stuff like yellow1.yellow.test.svc.local to just get us to this one guy, or yellow2, blah, 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 to just get us to this other guy. So this is my understanding of today. Okay, I have a few slides where there's a lot of words, which is kind of a bullet point version of what is in the spec. And then just to show you where this is going, there's also these diagrams, which is a version of this too. So hopefully for some people, this might be a little bit easier to follow. But the point I want to get across here is what I'm suggesting for cluster set IP services, and then same thing, what I'm suggesting for headless services and what those look like. So basically, if we live in a world today where single cluster DNS gets things like service.namespace.svc.cluster.local to try and route to one of potentially many pod backends that match a services selector, then what we want in the cluster set case is service.ns.svc.clusterset.local, and the magic is that this will now be able to route to any matching pods and the whole cluster set. So this is like kind of the basis of MCS, but no super major changes in terms of like the structure of this DNS besides the zone being differently. That's saying, hey, you could go bump out to like somebody else in the cluster set, like a yellow pod that's like over in cluster B instead of cluster A. So there's a lot of words for that, but those that's the main idea here. And the picture version is that if we had two clusters now that have pods that match our service color, so I've got my blue pods and I got my yellow pods, then blue.test.svc.clusterset.local should match to the cluster set IP, which can get to either of these places. And yellow.test.svc.clusterset.local should match this cluster set IP, and it should be able to get to either of these places on the A side or the B side. So that's it for cluster set IP. Hi to Tim.
So I've been vocal before about my distaste for the SVC syntax that we dreamed up for single cluster. But I also think that being different here probably is more harmful than valuable. So I waive that previously vocal objection. I want to ask though, we've always said from the beginning that the single cluster DNS suffix cluster.local was optional. I mean, was a suggestion and that people can change it. Most people don't. Some providers don't even allow you to change it. What is our feeling on this? Do we take the same stance? Do we require it be cluster set.local? I have, for context, I've been chided that this is not what local is for, and we should stop doing that.
Just from the perspective of the doc proposal, it's pretty wishy-washy. It's like you could configure this, but you probably didn't, which is matching some language that's on the MCS API doc right now, but definitely opening the floor if we want to change that in either or both places.
I think we haven't made a strong statement here because it needs to be discussed, but my personal stance would probably be to make it predictable. And if you want to use something else, that's fine. You can have an alias.
I think for me, principle of least surprise is like the dominant feeling that I have around this.
Okay,
Anybody else?
I think both of those are saying make it be cluster set.local and you can't change it.
I think that is what I'm also hearing, and I like the guidance. If you wanted a different name, go make aliases. It doesn't work super well when things are dynamic like headless.
That's true.
It's much easier to not allow it to be changed at first and to allow it to be changed later if there's a strong demand for that. So
yeah,
I think gravity works for us if we say you can't change it at first.
And this would work with an ingress controller just by pointing at the cluster set.local somehow.
you mean for the backends?
For if I wanted to expose this stuff outside the cluster set. So I have an ingress controller somewhere that I want to point to the cluster set.local.
Well, that depends on the ingress controller. Most ingress controllers that I'm familiar with don't actually use the names at all. They watch the services and the endpoints directly and reconstruct those into their own backend sets.
Okay. So there's going to be an endpoint list associated with the cluster set IP?
Yes.
Cluster set service, rather?
Right. That they would watch the endpoint slices and they would get the union of all the clusters.
Okay.
To them, it looks just like another local service, which I think is the real advantage of the design.
Okay. Thank you.
Okay. All right, so we're trending don't configure cluster set.local away, your cluster set zone. I'll definitely make the change in the doc, and then I know there's language in MCS API KEP right now that talks about it being configurable. So I don't know. I can just open a PR against that. I don't know what the process is for that one because it's further along.
I think
That's
open a
fine.
PR. Yeah.
Yeah.
Great.
Cool.
And I do think we should earmark it as we may come back to this and may make it a configurable thing.
Okay.
It's really a front end problem, not a back end problem.
Okay. Okay, cool. Just writing some notes. Great. Okay, so that's the cluster set IP situation. Headless services have more going on with them, which is that they get DNS records, one for getting back all the IPs for every pod back in the service selector, because the whole point is to give the consumer the ability to choose which one it wants to head to itself instead of letting Kubernetes choose for it. And then also one disambiguated DNS name. I need to move your videos again. I can't read per per pod backend. Whoops. Which basically uses the pod's host name to disambiguate. So the service.nns.svc.cluster.local. This is where you get the IPs for every pod. So you get 1+ IPs if you have more than one pod. This is kind of the normal case for headless, from my understanding. And then something like web-1, if this is the host name for one of those pods behind the headless service, then you get the IP for just the pod that has this host name, web-1. And then all the rest of this is the same. So since the second one is about disambiguating the pods by some property about them, their host name, since we live in a multi-cluster world, we need to disambiguate it also by something about which cluster it's in, particularly if the host name is the same in cluster A and cluster B, which seems possible. So the proposal here is to do, for the second one, host name dot cluster ID dot service dot ns dot svc dot cluster set dot local. So picture time looks like this. I'm going to move your videos again. Whoops. Okay. So the idea here is that you could still have these general ones and get back all the IP addresses. So blue.test.svc.clusterset.local. In the headless case, you get back the IP for this one and this one and this one and this one and this one, instead of just redirect through the cluster set IP. You get each of these individually and in both clusters, because we're multi-cluster people. And then if you want a disambiguated one, then if you want to get to just this blue line over in cluster A, you need both blue-1, and then you also need cluster A, or whatever the name of that cluster is, .blue.test.svc.clusterset.local, blah, blah, blah. This suffix is kind of the same. So this blue-1 cluster A gets to there, blue-2 cluster B gets over here, blue-3 cluster B goes over here, right? And then the same thing could be said for all of these yellows. So I'm not really showcasing it in this example, actually, but imagine if there was a yellow called 2 over here and a yellow called 2 over here as well, like they both had the same host name. Then because you have this cluster ID in the middle, you could disambiguate to yellow2.cluster A and yellow2.cluster B is the idea here. Any feelings, thoughts, questions, emotions about the headless case?
So what about if I want to hit any pod in the blue service that's in cluster A?
Any pod that's in the blue service that's in cluster A?
That is a good question.
Yeah.
And
I guess that's not a headless service, right?
right.
Well, I mean, it is still a headless service in that there's no VIP
cluster
for it, right? Yeah. It's just it's not a multi-cluster service. You're saying it's a single cluster. So the question, I guess, is, should we define that no prefix cluster A dot blue dot whatever resolves to all of the records, while each individual name resolves to the individual records, which would be the same shape as the single cluster, but with one extra token in there.
It would let you directly address a remote cluster, basically.
Yeah, but only for headless services.
Yeah.
Not for headful services. So is that actually a requirement?
My take from talking with folks on this is, well, it certainly seems intuitive. You remove a label and you go the next level up. It's great. But it doesn't actually seem like anyone needs that. And so I guess it does seem like more work and more requirements in the implementation. If nobody's actually got a use case other than seems like it makes sense, maybe we shouldn't start there. I'm curious if anyone knows of any actual use cases.
So in the absence of a use case, I'm happy to let folks tell us it's a requirement instead of deciding that it is.
Yeah, well, we have some use cases for basically sort of multi-clustering non-cloud native workloads that already have their own idea of what a cluster is. So typically replicating databases, for example, where they need to be able to address the actual individual hosts that constitute the cluster. And so there it's helpful to have a way of addressing individual components. And we also have some cases where some traffic needs to go to a specific cluster. We don't care where in that cluster, but cluster A.blue without blue one, that would be helpful. That's helpful too.
So for that first case, I think, do we cover that with the direct pod addressing for databases? Because I am familiar with like certain systems that needs to talk to blue one cluster A, blue one cluster B. That I think makes sense. The other case, are those actually then the same service? Because part of this has always been the idea that the
we've had
service
this
should be
discussion
fungible.
before. And they aren't from that respect. Yep. Yeah. So they should really have their own non-exported services, or at least
or maybe the service name becomes cluster A blue, and cluster B blue is actually the service name for those services, because I actually care which cluster they're in.
Yep.
Or
it has to be.
Sorry, Steve, go ahead.
Yeah, or it has to be covered by other concepts that we don't really have yet, like topology information on top of the MCS.
That's
being
a
able to
conversation
say,
to have.
Yeah, so that's part of what comes up next. So yeah, being able to say, I want to talk to this specific service, but in a different availability zone from me, or I want to talk to a service specifically in the same availability zone, or in a different, well, basically any topology item. But that doesn't really fit in with DNS.
Yeah, there's some work going on in SIGNet around automatically doing topology, but it's doing the opposite of what you just said, which is prefer to talk to the things in my same zone when possible.
Yeah.
So if we want to provide some way for explicitly targeting individual clusters by name, then we will have to build some concept of the cluster identifier into the name, which we have for headless, but we do not have for headful, right? And my concern here is if we're going to do it for one, we probably need to do it for both, which would mean thinking about extending the VIPI case further.
Or we have that already in the form of like actually making the service name in like named per cluster. So we just actually have different services.
In other words, push it back on the user.
Yeah.
Yeah, I think that's interesting in a sense that the other way I've kind of heard of this is if I had cluster west and I had cluster east and I wanted, or cluster EU and cluster US or whatever, that seemed to be a case that people had talked about. And then technically, since they can name their cluster whatever they want, even though we're recommending Cube ID, they could put human readable information in it. That is, I feel, what kind of led people to think that, oh, I could, encode that information basically in my cluster name, and then that should show up here. And then I think what Jeremy, you're saying is, if they were already encoding that human readable information somewhere in this whole line of things, they could put it in the service name.
Yeah, I mean, it seems like, at least to start, we have a solution. Maybe it's not the automated solution, but if what you actually want is a service in another availability zone, or like encoding it yourself in the name solves clusters. I think in the near term, like even if we included the cluster name and we gave you that cluster level addressing built in, first of all, I think it might encourage people to use a single service when they really should be using two. But it also doesn't seem like it actually addresses the separate availability zone, unless the user then takes on making sure that the clusters are each in a different availability zone as well. So if you wanted a Europe address and a US address, that seems like another thing as well. And all of it seems, to me at least, like it would be easier to just say, put it on the user, include that in your service name, and export these as different services, and then you have all of the knobs you want.
Yeah, especially since it feels really like a workaround for deficiencies in our ability to describe services and features that we desire of the services we want to talk to. And so not including a workaround in the spec seems like a good idea.
Cool.
Okay, so I'm hearing we don't want a separate record option for drop the host name just cluster dot blah 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 blah, which could get to, let's, for example, like just these guys over here or just these guys over there. And I'll put in some some of the examples conversation from this to motivate that in the proposal.
I think we should keep our ear to the ground for whether this is a common enough requirement that it requires or would be better with a systemic solution. But right now, I think this is the right call.
Okay. Cool. All right. So last slide. We brought up a couple other things that are not listed here, but these are some possible problems I've heard about. So just seeding everybody's brain, and we can discuss it now and or on the proposal. But yeah, basically for headless services, I mean, overall, the idea is to make sure the disambiguation is good enough. We kind of were just talking about that. And it sounds like a particular case where this has to really be good enough is for stateful sets, because they have state. And right now, stateful sets make special pod host names of this form, stateful set name dash ordinal. Like earlier on the examples when I said like web1, that's kind of an borrowing from that example, which is sticky to the pod. So between these unique host names and then cluster ID, the idea is that this is disambiguated enough for headless services. One thing that has been brought up to me is if a pod's idea of its fully qualified domain name is only the cluster local one, is stuff gonna get weird if that pod is self-reporting for some reason, it's not disambiguated enough name because it has only its cluster local DNS for our multi-cluster cases. And stateful sets might be the drama because I think it might be the most dramatic one, but this could be the case for any headless service.
So we know through SIGNet that there are a handful of cases where applications look at their own host name or their own FQDN as defined by hostname-f, or sometimes just by host name. Thanks, guys. Thanks, Red Hat. If that is a problem for them, for those apps, like they're using Kerberos, for example, then this will be a problem if they need to get multi-cluster resolution. There simply isn't a way to say use the multi-cluster suffix instead, because kubelet doesn't know about that. There is an open proposal to allow pod authors to specify their own FQDN that is only seen to them, right? Not in DNS, but is only seen to them. So that at least gives them the ability to take the reins here when they need to. So I think that will be enough to get over the hurdles for now, and we can figure out if there's some more systemic problems. TLDR, I think we're okay.
Okay, is this open proposal, is that a SIGNet thing?
Of course.
Of course. Okay, great. I'll stalk them more than I already was planning to stalk.
I'm happy to point you to it. We have a handful of customers who are, or users who are just saying, look, why do you care what my host name is? Just let me set whatever I want. And you know,
Gotcha.
they're right.
Okay, cool. So I'm taking some notes, probably okay. I have some other feelers out on this topic too, but I'll follow along that thread as well. Okay, so that is my story. This is basically this is the presentation version of this doc again. So please take a look at this doc and comment as you see fit. I'm also going to incorporate some of this feedback here as well, particularly about the why we're not going to support just clusterid.service.ns.svc.clusterset.zone. And also the other big edit I have in my notes is that, scrolling up, that cluster set zone should not be configurable until and unless we decide later that it should be. And then I think I'll put some comments here, but it sounds like we're kind of anti PTR records, or I guess like we get them a different way. We expect to get them a different way. So I'll put in the information about that. And then server records is still TBD. I'm going to talk to SIGNet about this. Cool.
Okay, that was a great presentation. I believe, Stephen, that you have something on the agenda next. Why don't you go ahead and take it?
Yep, thanks. So this is just really dipping toes to see if it's worth discussing further in this context. So we have a proposal in Submariner to add weighted load balancing of services across a cluster set. And we've discussed this here in the past already. The idea is to, and this is all implementation detail, for a controller somewhere to figure out how costly it is to talk to services in different clusters, and to give the right target back to requesters based on that. And we'd said in the past that ideally what we want is for just the right thing to happen all the time, and I think that's what the goal should be. And this is just sort of asking the general audience here if there's interest in more academic discussion of that, in which case I'd go off and prepare a slide deck with a lot more detail, or if the collective wisdom of the group is that the goal should really be do the right thing as far as MCS is concerned, and push problems out to other groups, for example, to determine what the financial cost of a given connection is, or ask the user to express, or, well, no, try not to ask the user to express performance characteristics and all that sort of thing. And the only thing I can see currently in the proposal we have that we'd want to ask the user is whether they want it cheap or fast, or some magic combination of the two, and that tends to be meaningless in the end anyway.
Go ahead, Tim.
So SIGNet is still dealing with this issue from a single cluster point of view, and we have in 21, which is due in weeks, a new change to add something called endpoint hints, topology hints, sorry, to endpoints, where every endpoint in a slice can include some hints about topology information that was decided by whomever created the endpoint slice. So in the single cluster case, that would be the in-cluster endpoints controller. In the MCS case, it would be whatever your MCS implementation is, which is supposed to be something that the proxy subsystem can then consume to make topology smart decisions. So for example, I can say, this endpoint, I've decided this endpoint is good for zones A and B, and that endpoint is good for zones C and D. And the decision there is pretty coarse. It's really about topology without a concept of cost, on the assumption that there's zero cost within a zone, non-zero cost between zones. And so we'll try to optimize for that. So I wonder if that is a good enough starting point to figure out the question that you're asking, Stephen, or if you really need more like cost-based information.
Yeah, it sounds like a very good starting point. Yeah, and I'm not sure what the cost aspects would be like. I think in most cases, yeah, like you say, it's zero within the same availability zone and something outside and probably fairly similar, or we don't care once we decide to incur some cost, how much that cost is actually going to be, you know, comparing zone A to zone B, for example, from zone C. Yeah, so that's definitely very helpful. Thanks.
Tim said everything I was going to say. I think that regardless of, I think this is a conversation that should involve SIG network regardless. I don't think we should try to design the optimal flow from the MCS standpoint only. I think starting with what they've been working on is probably good. And then if we were to determine that it didn't actually meet our needs, then starting with SIGNet on meeting those needs is probably going to end better than if we try to come up with a list of requirements separately.
Okay, well, thanks.
Was that all you needed, Stephen?
Yeah, for the time being.
Okay, well, I think we're about at time, and I think that was the last thing on the agenda. So thank you, everybody, for joining, and we'll see you next week. Have a great rest of your day and a great week.
Great meeting. Thanks, everyone.
Thanks, everyone.
Yeah. See you,
Bye.
everyone. Bye.
Bye,
See ya.
people.